So tell us about it, Tim.
Well, what we have here is the prototype experimental modulator for a xenon short arc lamp. This is a 200 watt short arc mercury xenon bulb. The fuzziness in here is mercury. This is an end-of-life bulb that I got surplus. The ship-to-ship project is planning on using a 7,000 watt version of this without the mercury. That's a good deal bigger than this, but it works on exactly the same principles. So I built this as a test bed for modulation techniques and power supply techniques to find out what it took to run this. Using a mercury xenon bulb is a lot harder than using a pure xenon bulb because the pressure inside the bulb is very low when it starts. It has to really heat up for like 3 minutes before it's at full power. What we've got here is a bunch of hand-wired power supply stuff. This forms a 700 volt power supply. This is a 12 volt power supply that runs the relays and the control logic. And over here is a 200 volt power supply. So the 700 volt power supply is attached to the ignition coil. The ignition coil is fired by the relay and this set of batteries. So these bulbs are really hard to strike. They take 35,000 volts to get them started. This supplies the starting pulse. Then the 700 volt supply kind of catches the arc and pulls it into a stable configuration. And then this timer runs out and this big contactor pulls in. The contactor is there primarily to isolate the modulator, which is up here, from the high voltage, because the strike voltage would blow the modulator out. So as soon as the time delay's passed, this pulls in and connects the bulb to the modulator. And the modulator is powered by this 400 watt, 48 volt power supply. This is overkill, but that's good. This has got a really big transistor in it and some extra goodies, including a little opto-isolator that tells this circuit when the bulb is drawing power. This bulb is extremely rich in ultraviolet. The actual xenon bulb I'm planning on using is not ultraviolet enhanced, so these won't be quite so necessary. Although at 1 billion candle power, it'll still be good to have them. So there's the strike, the initial arc. And then when the timer runs out, there you get the nice little controlled arc. Now I can control the background current through the arc, and right now I have to kind of manually turn it up and heat the bulb a little bit so that it's running better. The arc instability you see there is because it's an end-of-life bulb, an old surplus bulb. So then we can start some music. The music is hooked up to the modulator, and the modulator then adjusts the current through the bulb. And it's since it's not warmed up, it's really only running at about 35 watts. I'd have to hold it at this energy level for 3 minutes before it would come up to full power. It was kind of fun to watch it. Now this is not just blinking, this is actual audio coming out of the bulb. Okay, so if you look at the fluorescent light, you can see that's hum, right, coming from the fluorescence overhead. And then if I look, and the hum will be superimposed on the light. I haven't really got the modulator tuned, so this is a little clipped. And of course, this photocell is not really designed for audio, but there it is.